Hi, my name is Sayed Ahmed, a Senior Solutions Architect at AWS. Welcome to part 2 of the Microsoft on AWS Optimization video series. We will continue looking at Acme Financial Data Services' journey to optimizing their Microsoft workloads in AWS by focusing this video on managing Windows on AWS. Here's the story so far. In the last video, we saw how licensing was optimized with AWS Systems Manager. In this session, we will see what managing Windows Server at scale will look like for Acme Financial Data Services. Here's the current architecture for Acme Financial Data Services, or AFDS for short. In part 1 of the video series, we introduced AWS License Manager as a way to allow AFDS to bring existing Microsoft licenses into AWS and save on costs. Please watch part 1 of our Microsoft on AWS Optimization video series to learn more. This video will focus in part on the WSUS server that currently manages the patching of all Windows Server migrated into AWS. Since AFDS chose to lift and shift their environment into AWS, they brought their traditional systems management software and techniques into the cloud. This means they are leveraging traditional management software that is not built for the cloud or the scalability of AWS. Licensing traditional management software can be expensive and add overhead to their existing fleet of Windows servers running on EC2. AFDS would like to simplify remote administration as well. Such administrative tasks include managing updates for their entire fleet of Windows servers, deploying packages and new drivers at scale, and the ability to audit connection attempts and commands sent to these Windows servers. To improve the security posture, AFDS would like to reduce the need to publicly access Windows servers via remote desktop. And last but certainly not least, AFDS is looking to find a better way to scale the patching of their Windows servers. As we saw in the previous architecture, they are leveraging a WSUS server. AFDS wants the ability to patch their systems dynamically and without having to rely on an EC2 instance. AWS Systems Manager gives AFDS the operational insights into their Windows environments that are running on AWS. It provides a unified user interface so they can view operational data from multiple AWS services and allows them to automate operational tasks across their AWS resources. With Systems Manager, they can group resources like Amazon EC2 instances or Amazon S3 buckets, just to name 2 services, by application, view operational data for monitoring and troubleshooting, and take action on their groups of resources. Systems Manager simplifies resource and application management, shortens the time to detect and resolve operational problems, and makes it easy to operate and manage their infrastructure securely and at scale. To help AFDS, we will be focusing on 3 capabilities of AWS Systems Manager. We'll be taking a look at Run Command, Sessions Manager, and Patch Manager. With Run Command, this allows AFDS to remotely and securely manage the configuration of their EC2 Windows instances at scale. With Sessions Manager, AFDS can manage their Windows instances through a browser-based Powershell window, not having to require a remote desktop gateway connection. And with Patch Manager, AFDS can automate the process of patching their instances without relying on the WSUS server. Now, there are many more capabilities that are available with Systems Manager, and I encourage everyone to check out the AWS YouTube channel to learn more about this service. Now let's take a look at a quick demo of what this can look like for AFDS. So here we are in the AWS console. You can see the instances that I have launched for this demo. These are all running Windows Server 2019. And what I'd like to do is I'd like to be able to manage them using SSM, using Systems Manager, so to get an idea of what AFDS can do to manage their instances at scale as well. So one of the first things I need to do actually is ensure that I have a appropriate IAM role. So you can see there's no IAM role assigned to these instances, and the IAM role is key. So there's basically 3 key things you would need for any instance to be managed by Systems Manager. You would certainly need first and foremost, in no particular order, but first and foremost you would need the SSM agent. It's a lightweight agent that is installed on any Windows server or any Linux server. For the Amazon provided AMIs, the Amazon Machine Images for Windows Server, every version from 2019 and down, the SSM agent is automatically installed. For any instance that was lifted and shifted, that process that AFDS used to lift and shift, they would have to ensure that the SSM agent is installed as part of the migration. Or else they'd have to use some sort of orchestration method to install that agent. So that'd be the first thing. The second thing would be ensuring that there's some sort of communication, be it a NAT gateway or some sort of internet gateway if these are publicly accessible instances, so that they have communication out to the SSM endpoint. This is to ensure that there's communication back and forth between the EC2 instances and the SSM service. And third is, which is what we're going to focus on here, is the IAM role. This allows the instances, any instance with an appropriate IAM role, to have access, allowing access into SSM, and so that SSM can manage it and do the things it needs to do to let customers like AFDS work at scale. So what I'll go ahead and do here is I'll click on services, and I'll first go to the IAM console. So I can start typing in IAM, and here we are. So I'll click on this. And here we are in the IAM dashboard. So what I'll go ahead and do is click on roles, and I already have some roles that I have for my account, but I can create a new role, and AFDS can certainly do this as well. So I'm going to click on create role, and what I want to do is choose the service that I want this role to be assigned against. In this case, it would be EC2. So that I can assign this to the EC2 instances. So I'll click EC2 and click next to assign permissions. Now here's where you can either choose a set of managed policies. These are policies that AWS provides, or a whole host of policies that customers can choose from, or you can choose from a customly created policy that you can create or have created before. I'll go ahead and choose, for the sake of this demo, a managed policy that we provide to all customers. So I'll search for SSM. And the policy that I'm going to use is this one right here, the Amazon SSM Managed Instance Core policy. And this will allow the communication that we need for this instance for these instances rather, to communicate with SSM. So I'm going to go ahead and select this and click next, and I can choose to tag this new role that I'm creating. For this demo, I won't do that, but if you need to tag it for auditing purposes, AFDS would certainly like to do that, so they can do that. So give this role a name, and I'll give this a demo SSM role, and you can give this a description. Okay, and I'm going to click on create, and the role creation should complete, and there it is. So here's the demo role, and you can see here this is the policy that we just assigned to it. And we won't necessarily walk through all of it, but you can see that it has the appropriate policies that we will need to communicate with the SSM, and with the sessions manager, and with the run command as well. So this should suffice for our needs here. So I've created this policy, so I'm going to go back now to EC2. So again, I can either find it here or start typing in the service or the acronym if I know it. So I'm going to do EC2 right here. I'm going to click on that. And that's going to take me back to the EC2 dashboard, and I'm going to click on my instances. So what I can do now is one by one is attach the role. So this is something that, again, AFDS can certainly orchestrate if they needed to, using scripts or using any other orchestration method that they prefer. So we can click on security and click on modify IAM role. And this will allow me to now attach the role that we just created to each instance. So I'm going to choose the demo SSM role from my drop-down list and click save. And this will be applied, and I'll do this for each server here. Okay, and just to confirm, I'm going to refresh the screen, and we can confirm that each instance now has that role assigned to it. Okay. Right, so what we can do now is you can give it a few minutes to ensure that the role kicks in, and so then it can communicate with SSM. And a couple ways we can verify it is, what I'll do now is click on services, and I'll type in Systems Manager, or I can type in SSM, which is the acronym for the service. So I'll go ahead and open this in a new tab. And we can see if it's showing up as a managed instance. A managed instance simply means that the agent's installed and it's communicating, it has the right roles, and it's communicating with the endpoint. So we can see that it's not showing up yet. So one thing we can do is we can either wait for it, or in the instance of time, interest of time rather, I can go ahead and stop the instances and start them up. And again, this isn't a required step, but it's certainly something that you can do. And I'm going to do it for the sake of this demo to ensure that the role is actually applied. Okay, so we can see the instances are started and they're running. They're still initializing, but let's go ahead and see if they have now, if they're registering now with SSM. So I'm going to refresh this manage screen. And we can see now that while they're still not in the fully initialized state, or they're still initializing rather, we can see that they're already communicating with SSM. So this is good. So now we can go ahead and start administering the server. So in this demo, I have all private instances. In other words, they're not publicly accessible. So even if I wanted to open RDP access, if I want to allow inbound connectivity to 3389, at least publicly, I can't access it. Now, in the case of AFDS, they're going to have some of their administrators that they need to manage. They would want to manage their servers, and they don't want to make all of their servers publicly accessible just to administer them. So what's one way they can administer that? Well, if we go back here, one of the things we can do is go to Sessions Manager. So if you see here on the left, I'm going to click on Sessions Manager. And what I can do is start a session. And so I can pick any one of these servers and start to administer them. So in this demo, I'm going to show a really basic task. I'm going to create a new local user. So I'm going to choose Private Windows Server 1. I'm going to start a session. So what's going to happen now, in this case, it's opening a new tab, but what's going to happen here, as you can see, is a new PowerShell window is getting opened. And any moment now I should see the prompt, and I'll just press enter. Yeah, there you go. So I see the prompt here, and this is PowerShell. This isn't a subset of commandlets. These aren't AWS approved commandlets. I'm essentially able to PowerShell and run PowerShell commands on this Windows server here. So let's say I ran a pretty common command here, get process. I can see all the processes that are running on this server, just like you would when you're on the server if you've remote desktoped into it or remote PowerShelled into it. Same concept. And I have the same sort of the shell options that you'd expect to have. So if I wanted to tab complete, for example, I can do that, and I can tab complete if I wanted to find, let's say I wasn't sure what the service is called, get service. I tab completed that. I can sort of tab search, if you will, right? I can find all the commandlets this way. That's another option I have. I can Control C to exit out or to cancel this command. I can go up and access the history of the command list executed. So again, it's very common usage that you would have on a traditional command prompt window or PowerShell window. You can do that here. So as I mentioned, I want to create a local user. So if I run the get local user commandlet here, I want to create a local user in this on the server. So there's a user I'm going to call local admin that I will call local admin. You can see they're not here already. So I'll go ahead and type in or call rather the new local user commandlet. And just like I would on a traditional PowerShell window, like as I'm remoted into it, I can run the same commands here. So this is the new local user. I'm going to simply call it local admin. And I'll give it a password, and this password has to be a secure string, so I can pass the secure string in any number of ways. I can create a secure string variable, or I can be prompted to input it using the read host commandlet. So I'm going to pass this as a secure string and prompt myself to enter password. And you can use whichever technique makes the most sense to you or that you would prefer. And this is a very simple example of creating a local user. So I'm going to go ahead and press enter and type in a password for this administrator account. Okay, so I've done that. The new local user is created. So if I call the get local user commandlet, now you can see that user has just been added, which is great. But they're local admin, but they're not actually part of the administrators group yet. So I need to run another command called add local group member. The member is this new user that I've created, so it'll be local admin. And the group is the administrators group. And so I've now added this local admin user to the administrators group. So this is, again, a very basic example, but you can see I did all of this without having to remote desktop to the server first, without having to open any ports that allow remote PowerShell or anything like that. I'm just using Sessions Manager, really simple. So now what I'd like to do is do the same thing for the other servers, because as a one-off, Sessions Manager is really good to be to run these tasks on a single server. But I want to do something similar in a scalable way with the other remaining servers. So what I can do now is I can go to run command, and run command lets me execute a whole bunch of command documents. So if I click on run command, you can see I can choose from a whole host of command documents. Now AWS provides a bunch of documents already that you can use to administer your Windows and Linux servers. However, in this case, I want to specifically run one against the Windows server. And I'm going to call this one right here, AWS run PowerShell script. And what I can do for this one, I can input parameters, and the parameters are simply the PowerShell script. So if I have an existing script, for example, I can paste that in and then choose to run it against any target number of instances, which I'll show in a moment. But let me first paste the script. So I'm going to copy this and paste this here. So what I'm doing now is let me increase my screen here. So what I'm doing now, I'm running a very similar command, but there's a little bit of changes to it. So I'm passing a local admin variable, a local username variable of local admin, it's just a string. I'm creating a password variable, and I'm getting this value from parameter store. Now we're not going to focus on parameter store for this demo. Highly recommend checking out our documentation as well as the wealth of videos we have on our AWS YouTube channel around Systems Manager. But the parameter store is a place I can store strings and secure strings and use them in scripts and other methods to securely create passwords or database connections or whatever I need it for. And in this case, I stored a secure string password, which I'm going to then decrypt as it's getting called against this command. And then I'm going to then call the other two commands as you saw before, the new local user and adding the local admin to the administrators group. All right, so I'm going to execute this against a target set of instances, and I can choose I can choose a target in 3 different ways, either by key pair value, manually, or using a resource group. I'm going to choose manually in this case, although in the case of AFDS, they can certainly target a group of instances if they want to target them based on the key pair value or the resource group if they chose to. I'm going to choose these manually, so I'm going to choose 2, 3, and 4 because, again, I already did one manually with Sessions Manager. And then finally, as a way to audit this, I can enable S3 buckets to pass to, not pass, but to store the output in an S3 bucket. Perfect for auditing, a great way to keep track of what actions are being taken against an instance. Good for troubleshooting, good for remediation processes or to begin the remediation process. You can also choose to, in addition, choose to enable CloudWatch logs, another place to store this against. And what also makes this key too with either option is you can create triggers based on that and even create notifications so you can be notified, so the AFDS administrators can be notified when an action takes place. Really useful. I'm going to uncheck it for now for this demo and click run. And we're going to see now that this overall process is running, and we'll see the number of targets and the completion, and we can see individually how these fared as well. So let's give it a moment and we'll see how this completes. Okay, so we see that this has completed successfully and all 3 targets that were called were completed successfully. If there are any errors or any one of these targets failed or they timed out for any reason because the command was taking longer than the timeout period, then we'd see that here. We could also then see the specific details per target or in this case, per instance. As well. If you want to dig in, we can choose any one of these instances. Let's say I chose this one up here. We can see the output, and the output will vary based on what output you defined in your script. So this is the generic output that gets outputted when you create a new local user. So what we can do now is let's verify this. So I'm going to go back to Sessions Manager. And again, I don't have to remote desktop to verify any of this. I can do this straight from the console without having to open up any ports or make these servers publicly accessible. So I'll choose server 2, and I'll start a PowerShell session to that servers here. And then let's make sure it comes up. It may take a second or two. Okay, so I'll do the same thing. I'll do get local. I'll call get local user, and sure enough, you can see that local admin was created, and I just put in a description to make sure it's clear that was created using PowerShell from SSM. So this is really useful. So I'm going to go ahead and close this. So this is, again, a great way to perform tasks at scale, perform them securely without having to open up any ports or even requiring remote desktop. But of course, this is Windows Server, and there are going to be occasions where you need to administer something directly on the server. Perhaps you need to get onto remote desktop onto the server, access the GUI, and perform some task that either isn't too easy to do through PowerShell, or for whatever reason the task just requires it, that you're locally connected. So one way to get around this without having to, again, open up any ports or manage a remote desktop gateway of any type is to leverage Sessions Manager and to use the Sessions Manager plugin. So the Sessions Manager plugin is a command line based plugin, and it requires two main components. You need to install the AWS CLI, and the Sessions Manager plugin has to be installed as well. Both of those instructions and downloadables are available in our on the AWS website, and the instructions are available in our documentation. Highly recommend customers to check that out. But what I'll do is I'll clear my screen here, and I'll go ahead and paste in the command just to show you what it looks like, what the process looks like. This is pretty straightforward. So what will happen here is I'm pasting this command here. I'm basically calling the SSM service and to start a session, and I'm calling this specific target, which is one of the instances, so we can see which one it is. So if we compare that instance ID, that should be private server 3. So we're going to try to perform start a port forwarding session. We're going to call this predefined created by AWS document SSM command document called start port forwarding session. And the parameters that would be passed for this command document are which port do you want to forward, which port are you calling, what do you want to forward it to locally. So we're forwarding any 3389 request to, in this case, 56789 to a port, to the port 56789. So when I press enter, what you should see outside, if there's any, assuming there's no errors, you're going to see that the session started and this port has been opened. You can also see here, if we go back to Sessions Manager, if you refresh this, you can see that a new session has been started, and you can see it's calling this document in particular. And we can see the document details if you wanted to. Again, this is an AWS provided document. You can see it's really pretty straightforward. All it's doing is it's getting the port, the local port, and it's forwarding to the port of the service and forwarding it to a local port that we define. So we can now that we have this up and running, what I'm going to do is start a remote desktop connection window, and I can simply type in localhost, and then because I defined a different local port, I'm going to forward this request to 56789. And this is server 3, but you recall we created the local admin earlier. So I'm going to make sure to put in the local admin as the username, and this will prompt me for the password, and I'll go ahead and type in the password. And I'll press enter, and I should be connecting in there momentarily. You'll also see too that the connection was accepted in the command prompt window or in the PowerShell window here. So that's a good sign. And here you go. Any moment now, I'll be connected into the server. So this is another great way that AFDS can leverage SSM, and for those one-off instances, for those private servers that they need to connect to. This is a great way to connect to the server, and they can even see any connection attempts made using the port forwarding. So we've now connected via remote desktop to the server, again without having to open any special ports, without having to have a large management server or some sort of remote desktop gateway farm to create as sort of a bastion host. So we connected here. I'll go ahead and log out. We don't need to do anything else in here. And one thing I want to show too in terms of auditing, as I mentioned, is we can go back to Systems Manager here. If we click on Sessions Manager, we can see the session history. We can see all the Session Manager connection attempts, including this one, these port forwarding ones that we have here. So I'm going to go ahead and terminate this one manually. We should see that the session has exited, so that's good. So you can see here in the history, you can see all the connection attempts. So this is another great way to audit and see what sort of connections were made against which instances from which IAM users. So really useful. So now let's switch gears a bit. And let's now talk about patching. So patching was another one of those things that AFDS wanted to address. So if you recall from the architecture diagram, AFDS is brought in their WSUS server which was performing their updates for the Windows servers. However, they want to get away from that, and they want to find a more scalable, managed way to do it without having to use an EC2 instance and just one less bit of overhead that they have to manage from a server standpoint. So Patch Manager is a great functionality, great feature of Systems Manager that allows for that. So we can click on View Patch Baselines, and we can start the process here. So AWS provides a whole bunch of pre-configured patch baselines. You can see not just for Windows, but for a whole host of OSs. You see a lot of common flavors of Linux are supported and have patch baselines. The idea behind the patch baseline is you can define rules that you want to have approved, and then what will happen is based on the rules and how you assign them to each instance, be it manually or through some other automated means, which we'll show in a moment. In the case of Windows, the patch baseline will be defined, and based on the rules that are defined, the Windows Update API gets called per server, where this baseline is associated, and the updates will then be downloaded based on what's been defined in the patch manager here in the baseline. So the patch manager itself is not actually downloading the patches and then pushing them onto the Windows instances. Instead, what it's doing is defining the roles or the rules, and then the per server, the Windows Update API, as mentioned before, is then going to perform the task itself, and based on what's been defined, it will download those patches accordingly. So let's look at that in more detail. Let's click on, I just clicked on Create Patch Baseline, and let's give this baseline a name. So I'm going to call this Demo Windows Baseline. You can give it a description if you like. However, here we choose the operating system that we want this baseline to be defined against. In this case, we want Windows. So I'm going to choose Windows. And then we can start with the approval rules per operating system. So here's where you can get really fine-grained and be detailed. So you can see it's defaulting to all, but I want to only specify Windows Server 2019 because if you recall, all of these are based on Windows Server 2019 AMIs. So I'm going to choose Windows Server 2019. And then here's where I can start choosing the classification. So I certainly want all the critical updates. Let's say, for example, I also want all the security updates. So I can choose them here, the classifications. I can then choose the severity as well and get granular. So I can say, you know what, I definitely want all the criticals. AFDS may also want all of the important ones as well. And then lastly, AFDS can define the auto approval rules. And this basically says that you want to auto approve rules based on after a set number of days. You can choose 0 days, or you can choose greater than that. Really common for customers to choose 7 days, so that when a patch is made available, they want to wait 7 days before it's pushed out. Or X number of days, 14 days, 30 days, whatever makes sense for your schedule. So that this way, if there's any issues with patches, and that does happen from time to time, they're not installed on all the servers, and then you run into additional issues. So they're a great way to delay that process when needed. You can also see we can add additional rules, and this is useful too. So with this one baseline, you can define rules for different OSs too if you wanted. So within Windows, so I can make a rule for Windows Server 2016, and I can differentiate this with the 2019. Let's say I have a batch of Windows Server 2016 servers, but for this one, I specifically want the service packs, or I specifically want critical, for example, in terms of severity. I can define those rules separately. So I don't have to create a patch baseline per version of Windows. I can create a single one and then apply it separately per OS. So I can get pretty granular with this. So in this demo, I'm not going to do that. I'm just going to leave this one approval rule. And you can even add additional rules per application. So this is Microsoft applications. This isn't a Win32 any application available on the internet. This is basically any Microsoft application. So you can see, for example, let's say I have a patch baseline. I'm going to define one specifically for a group of Exchange servers that I have. I can choose Exchange server. Or if I want to also get patches for SQL Server, which is of course very common for Microsoft workloads, certainly for AFDS, they have a bunch of SQL servers. We can choose this as well. And then again, you can go get pretty granular. So you can choose the specific version of Exchange. Let's say they're running Exchange 2016. And let's say they have a fleet of 2017 SQL servers and 2019. So you can get really granular with the products you want. And then you can also choose the specific updates and classifications and the severity and again, set the auto approval. For this demo, I don't need that, but just showing that you can do that. You can break it down to that level. And then finally, we have exceptions. And this is really important too, because you can define approved of exceptions and rejected. So you can specify a comma separated list of specific approved patches based on the patch IDs, typically is KB and then 6 characters, just 6 digits after that. And you can specify this list. And this is important too, because they don't have to match these rules. So you may require that a group of Windows servers always get a set number of patches, regardless of what rules are here, because it's important for that fleet of instances, or the application, there's an application dependency and there's certain Windows patches that have to be installed. So you can be pretty granular with that here. Likewise, you can reject a specific set of patches for the same sort of reason or similar set of reasons. There's an incompatibility with an application, or that it'll break your workflow if you have this specific Windows update patch installed. And likewise, it will, despite the rules defined here, the rejected patches will not get approved. So you can define these, so you can get really granular with these rules. So I'm going to go to, again, I'm not going to define any for this demo, but you can define them in your environment. AFDS certainly will. So I'm going to click on Create Patch Baseline. And my patch baseline has now been defined. So I'm going to click on here. It's listed here. So I have a patch baseline. Now I want this baseline to be assigned to these instances automatically without me having to do a manual scan of some sort. So what I can do is assign these to a patching group. So I'm going to click on Modify Patch Groups. And here's where I can define a patch group that is associated with this baseline. And you can add multiple patch baselines. And these are basically key pair values that get created through SSM, and then that can be assigned to an instance, which I'll show in a moment. So I'm going to go ahead and create a patch group, and I'll give it a name of Demo Patch Group. But of course, AFDS and any customer using this can define patch groups based on based on more meaningful names. But what this will now do is that any patch group, any instance that is part of this patch group with this tag name, will then execute whatever patch baseline it has been associated with. In this case, it is this association, this demo Windows baseline. So what I can then do is go back here and then one by one, I can add a new tag. And again, this can be orchestrated if you're working with a larger fleet of servers. But in this case, I'll do it manually. So I'm going to create a new patch group. I'm going to go ahead and create a new patch group with that patch baseline. So this is important. The key has to be patch group, and it has to be case sensitive and written like this. But the value will have to be whatever the group name is that you defined, as we defined earlier. In this case, it's demo patch group. So now this instance is part of this patch group, and it will then adhere to whatever patch baselines it has been associated with. Again, this was the one that this one is associated with. So I can then create a tag for all of these servers, and they'll fall in line with this patch group. If I create multiple patch groups, those instances can be defined to those patch groups, and they will again conform to the baseline that I've defined. So this is good. So now what I want to do, the final step, is I want to configure a schedule for these patches, because I don't want to run these manually. I want these to run, in this case, I'm going to show how AFDS can run these every night. So I can click on Configure Patching. And I can do it per instance based on their tag. I can choose the instances manually, or I can enable a patch group, which will make this a bit more dynamic, and I don't have to worry about which instances get created and added, because you can imagine AFDS will be able to add new instances using other techniques such as auto scaling, or any one of our other services that will dynamically add net new workloads. So I'm going to choose the patch group that I defined earlier, and I'm going to define a maintenance window, which is actually another feature of Systems Manager, which we're not going to go into too much depth with, but I will use that functionality to create a schedule. So if you had an existing maintenance window, you can choose that. You can even skip it and just install patches manually and have them run installed now. But I'm going to create a schedule, and this is something that AFDS wants to leverage. And I want this to run every day at, let's say I want to run it every day at 1 a.m. By setting the schedule for 1 a.m., this means that any instances that are part of this patch group will attempt to be executed at 1 a.m. So after setting the time, I need to set a duration. 1 hour is okay for AFDS in this case. And now I'm going to name the maintenance window. I'll simply call it something like demo MW. And now I'm going to choose the patching operation. So I have two options, scan and install or scan only. Scan only is useful when you need to see if there's any patches that are missing. But in this case, we want to not only scan, but we also want to install any patches that are available. Scan only is really good for reporting purposes. So now we're going to go ahead and configure the patching. So now that we've configured this, now the patch baseline that we had defined earlier with the associated patch group will execute at the given time, in this case 1 a.m. And this will allow AFDS to get the updates to their Windows server without having to require any sort of EC2 instance or WSUS server to supply these patches. With the AWS Systems Manager, AFDS was able to remove the WSUS server from their existing architecture. Patch Manager can manage the patching of the EC2 instances running Windows Server instead. In addition, Run Command allows AFDS administrators to execute commands remotely, securely, and at scale. And Sessions Manager allows for secure administration of Windows Server with a browser-based Powershell window. And finally, all of these capabilities are made available at no additional cost to AFDS. AWS Systems Manager is available to AFDS and other AWS customers without any upfront fees or licensing. AFDS will simply pay for the resources they use. In this session, we showed how AWS Systems Manager simplifies the management and governance by showing how you can execute commands at scale with Run Command, connect interactively using PowerShell with Sessions Manager, and build scalable patch baselines with Patch Manager. Don't miss the rest of the videos in the optimization video series. The next video, part 3, will show how AFDS optimized their SQL Server environment on AWS. Thanks for watching.